Okay, so today we are looking at the properties of a square root graph. And then today we'll just graph from the calculator. Tomorrow we'll talk more about graphing on my hand. So, what is the opposite of a square root? A square. So if you look at these graphs, if you turn them sideways, they're always going to be half of a parabola. Okay? So it's just half of a parabola turned sideways. Now if you wanted to graph the whole thing and you went this way, then it wouldn't be a function. Remember, you don't want a function, or a function can't have two y values for the same x value. So it's always just half of them. It always has a starting point on one end, and then it goes forever on the other end, whether that's left or right, just depends. So we've already talked about most of this stuff, except for one little thing, but let's just refresh our memory. Does anybody remember what the domain is?
Like, I was always taught that we get the domain it's like
So it was all reals because we were talking about parabolas. But now we're not talking about parabolas, so it's going to be a little bit different. But the domain is all of the x values. And so we want to know how far left and right the graph goes. So if domain is all of the x values, what do you think range is? All the y values. Good. So range is all of the y values. And on the graph, it's how far down and up the graph goes. And then the other thing that we talked about was increasing or decreasing. So remember, to determine whether the graph is increasing or decreasing, then you read it from left to right. So same as the parabola, you're reading it from left to right. And then one thing that we didn't talk about with parabolas, but we want to look at with this, is called the end behavior. Yes, end behavior. And so that is, where is your graph going as your x values are getting bigger and getting smaller? There's always two statements, because you always want to look at what's happening on the left side of the graph, what's happening on the right side of the graph. Okay. Questions? Okay. Alright, let's look at this first one. So the first one, it gives us this graph. So the first thing we want to find is domain. So if I'm looking at this graph, if I go to the left, I'm starting at 0. Do I have anything that's less than 0? No, because it starts at 0. And then how far does it go to the right? Infinity, good, because it has that little arrow. So then our domain would be 0. It's a closed circle. So less than or equal to x. And then on the right it goes forever, so less than infinity. You could just say x is greater than or equal to 0 if you want to. You can always drop the infinities. Okay, so left it went to 0, right it went forever. Okay. So then for the range, we're looking at the y values. So if I look at my y values, again it starts here at 0, and how far up is it going to go? Is it going to go past 3? Yeah. So as it keeps on going, it goes past 3. So then our range is the same thing. So 0 is less than or equal to y, because we're looking at the range. But then on the right, it's going forever, so less than infinity. Questions? So if we read this graph left to right, is it increasing or decreasing? Increasing. Is it ever decreasing? No. So in a parabola, one side was increasing, one side was decreasing, or vice versa. But with a square root, it's either going to be increasing or it's going to be decreasing. Okay? So this one is never decreasing. Okay? It's always increasing. So remember, to write it, we always use the x. And we don't have a vertex in this, but we do have a starting point in these, which at ours is 0, 0, so 0. So am I increasing when x is greater than 0 or less than 0? Greater, because my x's are going 1, 2, 3, 4, 5, so those are getting bigger. So when x is greater than 0. Questions? Okay. So then in behavior always has two statements. So you always have two statements. It always starts with x. So you want to know what's happening on the left side, what's happening on the right side. So as x approaches negative infinity, and as x approaches positive infinity. Okay? It always starts with that. So as x goes to negative infinity, as x goes to positive infinity, we want to know what does y do. So y approaches something, and y approaches something. So every single time you're doing in behavior, you can start with this. Okay, so this is always the same. As x goes to negative infinity, y goes to something. As x goes to positive infinity, y goes to something. Okay. So if I start in the middle of this graph, as my y's go to as my x goes to negative infinity. So as I'm going to the left here, my y's go to 0. Good. So then, again, we'll start in the middle. As my x's are getting bigger, what is my y approaching? Infinity. Good. And that's it. So the first part is always the same. All you have to decide are those last two things. Questions? Alright, let's look at one more together. So let's look at this one. So on this one, our special little starting point here is at 1, 2. So if we're looking at the domain, again, we want to know how far left does it go, how far right does it go. So this one goes to the left until we get to 1. Again, it was a solid line or a closed circle, so that's less than or equal to x is less than. And then how far is it going to the right? Good, infinity. Questions? Alright, so then if we're looking at the range, we want to know how far down does this graph go. So what's my smallest y value? 2. Is less than or equal to, and again now we're looking at y's because it's the range. And then how far up is it going to go? Good, infinity as well. Questions? Alright, so if we look at this and we read it left to right, is it increasing or decreasing? Increasing, so it's never decreasing. But it's increasing. Again, we start with x, and our starting x is 1. So as we increase, our x is greater than 1 or less than 1? Greater than. Good. Any question about those things? Alright, so then in behavior, again, we can always start as x goes to negative infinity, y goes to something. As x goes to positive infinity, y goes to something. Ah. For this one, yes, but not always. We'll look at one in a second where it's not. So if we look at this one, we start in the middle. As my x's are getting smaller, where's my y going? To 2. Again, if we start in the middle, as my x's are getting bigger, where's my y going? Infinity. Good. Which I tried to tell you before you knew. Questions. Okay. Alright, so this last one, it doesn't give us the graph. So the first thing we want to do is graph it. And we'll talk more tomorrow about specifically how to graph it by hand. So for today, we're just going to type it into y equals. So go to y equals, clear out if anything's in there. If any of your plots are highlighted, just go up to them and hit enter. And then that turns them off. If they're on, it won't let you graph. So then we want to type it in just like it looks. So the negative, not minus, but negative. And then the square root, which is second, and then the x squared, which is like diagonal from the 7 right here. And then we got x plus 2. And we'll graph it. So again, type it in just like it looks, graph. So for today, we're just going to pick a couple points, and like I said, we'll talk more tomorrow. So if I want to find these points, I go to my table, and depending on where you're looking, I've got errors all over here. So that's where you don't have a graph. So the first point you want in this one is that -2, 0, so we'll graph that one. And then we have a point at -1, 1. Or sorry, -1, -1. And then my next nice point is at 2, negative 2. And that's all we need for today, so we'll just graph it like this. Okay. So again, you want to start at the first real point that don't say error, and then you can just graph your next nice ones. Any question about getting that graph, the table, anything? Alright, so now we have our graph, so we can go ahead and look at our domains and our ranges. So if I look at my domain, how far left does this graph go? To negative 2. And how far right is it going to go? Infinity. Good. Now on this one, our range is a little bit different because how far down does this graph go? So it goes down forever. So negative infinity. Good. And then how far up does it go? So negative 2 is my x. What's my y? 0. Good. Good. So this one is backwards from those top ones because it's going down instead of going up. No, you don't have to have that. You could just say y is less than 0. Yeah, you never have to have the infinities. It just helps you with the pattern if you say down, up, left, right. So then, if we look at this graph, is it increasing or decreasing? Decreasing. So it's never increasing. So then our x is x, and our starting x was at negative 2. Yes. I don't know if yours is backwards or not. So if I'm looking at negative 2, I'm decreasing as I'm going to the right. So my x value is getting bigger or smaller? My y's are getting smaller, but my x's are getting bigger. Good. So if I look here, my next one is negative 1, 0, 1, 2, 3, 4. So my x's are getting bigger. Your y's are getting smaller because it's decreasing, but your x's are still getting bigger. Good, 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 good. Alright, so then in behavior, you always say as x goes to negative infinity, y goes to something. And as x goes to positive infinity, y goes to something. Okay. So in this one, as x goes to negative infinity. So if I start in the middle and I go to the left to negative infinity, where's my y going? 0. Good. And then if I start in the middle, as I go to the right, where are my y going? Negative infinity. Good. Questions? Okay. Alright, flip this paper over.